Okay, good. We can start today's lesson. This is the third lesson of heat. Okay, so up to now we have discussed about MC theta equation and heat capacity. Okay. Now the first topic of today is thermally contact. Thermally contact of two bodies. That's the topic. Thermally contact of two bodies. Thermal contact of two bodies. Okay. So, what is the thermal contact? Suppose now there are two objects or two bodies A and B. So, what is the meaning of they are in thermally contact? They are in thermally contact. Okay. I will take an example. Suppose there's a fire nearby me. Okay. So as I close to that fire, then I can feel the hotness of that fire, no? Hotness of that fire. The same thing can be, you can feel the same thing when cooking something, no? So when you are cooking something or when you do any heat related process, you can feel the hotness or coldness. You can feel the hotness or coldness. Sometimes you may open your refrigerator. Then you can feel the coldness. What is that feeling? What is that feeling? When I close to a fire, I can feel the hotness of that fire, Puti. That means the heat energy of that fire has been transferred to my body. That means that where I can feel the hotness due to that heat transfer. Okay. So when I touch a heated object, sometimes you may touch the iron. No? When you are ironing, you can touch touch the iron. So when you touch the iron, we can feel the hotness. Or if we touch any heated object, we can feel the hotness. On the other side, when we touch a cold object like ice cube or something, we can feel the coldness. So what is the reason behind that? The reason behind that is the heat transfer between two bodies. Therefore, thermally contact of two bodies means like that too. That means if there are two objects, situated close to each other and heat energy of one object transfers to the other object, then those two objects are said to be in thermally contact. Actually, when two objects are in thermally contact, it may be a physical contact or it may not be a physical contact because heat energy can transfer in three ways. One is conduction, convection, and radiation. So if heat energy transfer through conduction, definitely there should be a physical contact. There should be a physical contact නේ. හරි. දැන් ඕගොල්ලෝ මොකක් හරි උයනකොට ඔය තියෙන පුතේ මේ මෙටල් හැදි තියෙන්නේ. දැන් ඒකක් අල්ලලා බලන්න මොකද වෙන්නේ? ඒක ඇල්ලුවොත් අනිවාර්යෙන්ම වාට heat එකක් දෙන්න ඕනේ. So that is heat transfer through conduction. But when I close to fire, actually I do not touch the fire. Although I do not touch the fire, I can feel the hotness. That means heat is transferred. Heat is transferred from fire to me. It can be occurred due to radiation as well as convection. Therefore, when two objects are thermally contact, heat energy from one object can transfer to the other object. Therefore, if there is a contact in such a way, we call it as a thermally contact. Is that clear? If it is clear, please raise your hand. You have to remember, thermal contact means it may not be a physical contact, or it may be a physical contact. What can be happen? Okay. Then I done that. If two objects exist only, if two objects exist in such a way that the heat energy from one object can transfer to the other object, come on. Then the two objects are said to be in thermally contact. Thermal contact. It either be a physical contact or it either be a physical contact or non-physical contact. Non-physical contact. Because heat can transfer, because heat can transfer because heat can transfer in three ways. Sorry, in three ways. In three ways. Conduction, convection, radiation. Megapute, conduction requires the physical contact with it. It requires a physical contact. In convection and radiation, they do not require any physical contact. Yeah. Example. Number one. When we cross to a fire, we can feel the hotness of the fire. When we close to a fire, we can feel the hotness of the fire. When we close to a fire, we can feel the hotness of the fire. That means that means the fire and us, that means the fire and us. That means the fire and us are in thermally contact. That means the fire and us are in thermally contact. But it is not a physical contact. But it is not a physical contact. ගිනි තියාගත්තොත් නම් ඉතින් ෆිසිකල් කන්ටැක්ට් එකක් වෙනවා. ඒ අරුණා ෆිසිකල් කන්ටැක්ට් එකක් නෙවෙයි. Okay. Then the second thing. Second thing. We can feel a hotness. We can feel a hotness when we touch a heated object. When we touch a heated object. Another. So what is the reason to feel the hotness, Bhuti? What is the reason to feel hotness? The reason is the heat energy is transferred from the heated object to us. The heat energy is transferred from heated object to us. So due to that heat energy, our body temperature increases. Therefore, that is the reason we feel the hotness. Okay? That is the reason we feel the hotness around that area. Yeah? So, when we feel a hotness, that means we are in a thermal contact in between that heated object with that heated object with it. Therefore, if we cross to a heated object, sometimes we cross to a heated object, sometimes we can touch a heated object, we can feel a hotness, we can feel hotness with it. So that is because heat energy from that heated object is transferred to our body. Therefore, that heated object and our body is in thermal contact. Therefore, two objects are in thermal contact when heat energy from one object can transfer to the other object. If you got my explanation, please raise your hand. තේරුණා. I need response from everyone. Okay, කතාගන්න පුතේ. හරිනවද බලන්න. In both cases, we feel hotness as the heat energy is transferred from the heated object to our body. In both cases, we feel hotness. In both cases, we feel hotness because, as the heat energy is transferred from the heated object to our body. That means that means that means they are in thermally contact. They are in thermal contact. All right. Okay, Putin. Now, according to our explanation, if two objects are thermally contact, heat energy from one object can transfer to the other object. Now we can see what will happen or what happens, what can happen during this heat transformation or heat mobilization of heat. Okay. So we call it as flow of heat. Flow of heat. Flow එකක් කියලා කියන අපි. Flow of heat. Therefore, if there are two objects, which are in thermal contact, then definitely there should be a flow of heat from one object to other object. Now we are going to discuss the mechanism. Okay. Favorite topic? Flow of heat energy from one object to another object. මම ආයි කියන්නේ පුතේ අපි මේක නිකන් ඉක්වේෂන්ස් එකක් දීලා කටපාඩම් කරගෙන කියලා කියන්න පුළුවන්. ඒ වුණාට මෙලෝ තේරුම් ගන්න නැතුව මේක ඉස්සරහට යන්න බෑ. හරිද? මම ඔයගොල්ලන්ට කලින් කිව්වේ ඒ කියන්නේ අපිට ඉක්වේෂන්ස් කොහොමද මේක ඩිරයිව් වෙන්නේ මොකද්ද මේක ඇතුලේ තියෙන්නේ කියන්නේ හරියටම තේරුම් ගන්න ඕනේ. එහෙම තේරුම් ගන්න නැතුව හීට් කියලා ලෙසන් එක ඇත්තටම හීට් නෙවෙයි අනිත් ඒවා තේරුණා. හැබැයි හීට් වලදී හරියටම මේකේ ඇතුලේ මාරම තියරි කොටසක් තියෙනවා. මේ තියරි ඇතුලේ හරියටම තේරුම් ගන්න නැතුව හිමින්සලේ හරි අමාරු යනවා. ඒ නිසා තියරි තේරුම් ගන්නවා වගේම ඇප්ලිකේෂන් පැත්තත් දැනගන්න ඕනේ. ඇප්ලිකේෂන් පැත්ත කොහෙත්ම තේරෙන්නේ නැහැ තියරි දැන් නැත්තම්. හරි. මොකද හීට් කියන එක අනිත් අපි මෙකැනික්ස් වගේ නෙමෙයි. දැන් මෙකැනික්ස් වගේ ගත්තොත් එහෙම අපිට ඒක ඩේ ටු ඩේ ඇප්ලිකේෂන්ස් වලදී පම අපිට ඒක නිකන් පේනවා. අපිට ගොඩක් ඇප්ලිකේෂන්ස් අපි දැකලා තියෙනවා. ඒව ඔස්සේ අපි හරි අපිට හිතන්න පුළුවන්. නමුත් හීට් වල තියෙන ගොඩක් ඇප්ලිකේෂන්ස් අපිට ඒක ඩේ ටු ඩේ ලයිෆ් තියෙනවා. නමුත් සමහර ඒවා ඒක තියරිටිකල් එක්ස්ප්ලেইন කරගන්න බෑ හරියට අරගෙන දැන් නැත්තම්. ඒක මම මේ කියන්නේ මම ඒකන්නේ බොහොම හැම කොටසක්ම මම එකින් එක පැහැදිලි කරන්නේ ක්වෙස්චන්ස් හදන්න කලින්. හරිද? ක්වෙස්චන්ස් හදන්න කලින් හැමදේම තේරුම් අරගන්න ඕනේ පුතේ මේක හරියට වැඩ යන්න. හරි. හොඳයි. බලමු අපි ඊළඟට. මොකක්ද? Flow of heat energy. Flow of heat energy from one object to another object. හරි. Suppose today there are two objects, A and B. Now they are in thermal contact. One object is at 70 Celsius, other object at 30 Celsius. Right? Right. Suppose they are made out of same material and all are same. Right? You know, as the temperature of object A is higher than the temperature of object B, definitely, you know, the kinetic energy of particle depends on temperature. Therefore, internal kinetic energy of particle in object A definitely higher than that of object B. Therefore, as temperature A is higher than temperature B, as kinetic energy depends on temperature, I can say kinetic energy of A is higher than internal kinetic energy of B. Internal kinetic energy of B. Therefore, now it is very clear there is an energy difference. There is an energy difference between two objects. As there is an energy difference between two objects, definitely there will be an energy flow. Energy flow from one object to other object because there's an energy difference. This energy is higher than this energy. Therefore, there's an energy flow from one object to other object. That means here A, here B put A. Therefore, there's an energy flow. Actually, this energy is kinetic energy put A, internal kinetic energy. Therefore, there's a flow of internal kinetic energy. There's a flow of internal kinetic energy from A to B put A. Actually, if there's a flow of internal kinetic energy, that means definitely should be a heat energy because heat energy consists of internal kinetic energy and potential energy. Therefore, if there is a change in that kinetic energy, definitely it should be due to heat energy. Therefore, if there's a flow of energy, flow of internal kinetic energy, it should be a heat energy. It should be a heat energy. Internal kinetic energy का transfer रखने के लिए heat energy का. Internal potential energy का कहते हैं मेरा से रखने के लिए heat energy का. Therefore, definitely there should be a heat flow. There should be a heat energy flow from object A to object B because internal kinetic energy of A is higher than the internal kinetic energy of B. Due to this heat flow, kinetic energy, internal kinetic energy of A decreases. Therefore, internal kinetic energy of A decreases, and this heat energy is received by B put A. As a result of that, internal kinetic energy of B increases. So as a result of that, what will happen? When the kinetic energy decreases, definitely temperature of A definitely it will decrease with A. The temperature of A decreases. And temperature of B definitely increases. Is that clear? පැහැදිලි. තේරුණා නේද උස්සන්න? මොකක්ද වෙන්නේ කියලා? අපිට මේක බොහොම ලස්සන එක්සැම්පල් එකකින් මට මේක පැහැදිලි කරන්න පුළුවන්. හරිද? ඔන්න බලන්න එක්සැම්පල් එකකුයි. ඔන්න ඔතන තියෙනවා metal ball එක. metal ball එක 7 degree වලට රත් කරනවා. Now there is a water container. Water container at 36. Now I am going to put this metal ball into this water container. So if I put this metal ball, what will happen? If I put this metal ball, then what will happen? What will happen? Now the temperature of A is higher than temperature of water. Therefore, kinetic energy of A is higher than the kinetic energy of B. Now there's a heat transfer from A to water. Now there's a heat transfer from A to water. Now there's a heat transfer from A to water. So as a result of that, what will happen? As a result of that, what will happen? Temperature of water increases, temperature of metal ball decreases. Temperature of A increases, so it decreases, temperature of water increases. Therefore, temperature of A decreases and temperature of water increases. Yeah. අපි මොකක් හරි රත් වෙච්ච ගාම මේක කූල් කරගන්න ඕන නම් මොකද කරන්නේ? දානවා වතුරට. අපි මේක කරනකොට තේරෙන්නේ රත් වෙච්ච එක ටක් ගාලා කූල් කරගන්න ඕන නම් දානවා වතුරට. දාපු ගාම මොකද වෙන්නේ? අරක කූල් වෙනවා වතුර එක රත් වෙනවා. ඒක අපි දැකලා තියෙනවා. පැහැදිලි? ඔක තමයි. ඔන්න ඔක තමයි. මොකද වෙන්නේ? If temperature of one object is higher than the temperature of other object, definitely kinetic energy of the first object is higher than that of the second object. Therefore, there will be a energy flow. There will be energy flow from the high temperature object to low temperature object. As a result of that, kinetic energy of the first object decreases, kinetic energy of second object increases quickly. Kinetic energy depends on temperature. Actually, temperature depends on kinetic energy. Therefore, when kinetic energy decreases, the temperature of first object decreases, temperature of second object increases. Temperature of second object increases. Therefore, when two objects are in thermal contact, and if there's a temperature difference, then there will be a heat transfer from the hotter object to cold object. And is that clear? If it is clear, please raise your hand. I need responses from everyone. පැහැදිලි නැතු උස්සන්න. තේරුණා නම් කිව්වේ. Thank you. එහෙම දාගන්න. Consider two objects A and B. Consider two objects A and B. which are in thermally contact. Which are in thermally contact. Suppose the temperature of A, T A. Suppose the temperature of A is higher than the temperature of B. Suppose the temperature of A is higher than the temperature of B. Okay. Now, please draw this one and write up to this method. Write up to this level. Don't write this one. Write up this. Hello, Buddha. There I done this. Therefore, kinetic energy from of A, kinetic energy, therefore kinetic energy from A, from A, sorry, we have that. Therefore, kinetic energy transfer. Therefore, kinetic energy transfer from A, kinetic energy from A, therefore, kinetic energy transfers from A to B, from A. Therefore, kinetic energy transfers from A to B. That means when two objects are in thermal contact, when two objects are in thermal contact, when two objects are in thermal contact, that means when two objects are in thermal contact, come on, heat energy will be transferred from the higher temperature object to the lower temperature object. From the higher temperature object to the lower temperature object. Write it another paragraph. As a result of that, as a result of that, as a result of that, the kinetic energy of A, the kinetic energy of A decreases as the result of that. The kinetic energy of A decreases while the kinetic energy of B increases. Therefore, the temperature of A decreases. Therefore, the temperature of A decreases and temperature of B increases. Temperature of A decreases and temperature of B increases. Right. Now you can draw from here and write this example. Write this example. Quickly. හරිද? මෙතන ඔයගොල්ලෝ මතක තියාගන්න උසා තේරුම් ගන්න කාරණයක් තියෙනවා. මොකක්ද මේක? ඇත්තටම මෙතන අර ටෙම්පරේචර් ඩිෆරන්ස් එකක් තිබ්බොත් තමයි හීට් ෆ්ලෝ එකක් තියෙන්නේ. ටෙම්පරේචර් ඩිෆරන්ස් එකක් තිබ්බොත් තමයි හීට් ෆ්ලෝ එකක් තියෙන්නේ. ඇයි? පුතේ පොටෙන්ෂල් එනර්ජි එක තනිකරම ඩිපෙන්ඩ් වෙන්නේ අර ඉන්ටර්නල් බොඩි ස්ට්‍රක්චර් එකත් එක්කනේ. ඒ ඉන්ටර්නල් බොඩි ස්ට්‍රක්චර් එකත් එක්ක ඩිපෙන්ඩ් වෙන මේකද පොටෙන්ෂල් එනර්ජි එක ඒක වෙනස් වෙන්න නම් අනිවාර්යෙන් මෙතන ෆේස් චේන්ජ් එකක් වෙන්න ඕන. එහෙම තමයි මේක වෙනස් වෙන්නේ. හරිද? දැන් මෙතන එහෙම ෆේස් චේන්ජ් එකක් තියෙන අවස්ථාවක් නෙමෙයි. ඒ නිසා මෙතනදී කියන්නේ ෆේස් චේන්ජ් එකක් නැතුව මේ වගේ තැනකදී අනිවාර්යයෙන්ම මේ හීට් එක ට්‍රාන්ස්ෆර් වෙන්නේ තනිකරම කයිනටික් එනර්ජි එකේ තියෙන ඩිෆරන්ස් එක නිසා. කයිනටික් එනර්ජි එකේ තියෙන ඩිෆරන්ස් එක නිසා. හරිද? ඒක නිසා මෙතන අනිවාර්යෙන් ටෙම්පරේචර් ඩිෆරන්ස් එකක් වෙනවා තමයි. හරිද? ටෙම්පරේචර් වැඩි තැන ඉඳන් අර තැන තමයි හීට් එක ට්‍රාන්ස්ෆර් වෙන්නේ ෆේස් චේන්ජ් එකක් නැත්තම්. හරිද? ඒක දාගන්න. Take a special note tag දාගන්න. Write down as a special note. When there's no phase change, when there's no phase change, heat always transfers, heat always transfers from high temperature place to low temperature place. From high temperature place to the low temperature place. Okay. දැන් හිතන්න පුතේ. The previous example, okay? Initially, this was as 30 Celsius water. Now, I'm going to put this metal ball in to this water. So, when the metal ball in this water, what will happen? As the temperature of metal ball is higher than that of water, there will be heat flow from A to water. There will be heat flow. There will be heat flow. Then, due to this heat flow, what will happen to the temperature? TA and TB. What will happen to the temperature of A and temperature of B? Initially, this was 70 Pute, this was 30 Celsius. Then, after a certain time, this temperature decreases while this temperature increases. එනම් කොහෙද බලන්න? එහෙනම් මෙයා 60 වෙන්න පුළුවන්, මෙයා ඕන 40 වෙන්න පුළුවන්. Then 55, 45 වෙන්න පුළුවන්. So after some times, it can be 50 and 50. මේක actual values නෙවෙයි මම මේ assumption values assume value තියෙනවා. මොකද වෙන්නේ? This temperature decreases while this temperature increasing. Then after a certain time, මෙයා උඩ ඉන්නේ මෙයා යට ඉන්නේ. මෙයා උඩ ඉන්නේ මෙයා යට ඉන්නේ. So what will happen? What will happen when they are in thermal contact? This temperature decreases while this temperature increases. Therefore, after a certain time, both temperature comes to equal condition, equal position. If they are equal, if temperatures are equal, you know the kinetic energies should be equal. If the kinetic energies are equal, then at that point, from that point onward, there won't be any net heat flow Putin. Net heat flow, because now energies are equal. Now energies are balanced Putin. Now energies are balanced. So from that point onward, now there's no net heat flow. No net heat flow. This situation is called the equilibrium condition or thermal equilibrium condition. Thermal equilibrium. Thermal equilibrium. So what is the term thermal equilibrium? When two objects are in thermal contact, heat energy transferred from higher temperature object to lower temperature object. As a result of that, temperature of high temperature object or heated object decreases while the temperature of cold object increases. So after a certain time, the temperature of both objects become equal. So that point is called thermally equilibrium condition. At thermal equilibrium condition, Pute, kinetic energy of both objects are equal. Therefore, there is no net energy transferred from one object to other object. Is that clear? If you got what is thermal equilibrium, please raise your hand. I need responses from everyone. But Hamon give me responding on. Question at hand. Thank you. There I copy. Thermal equilibrium condition. Thermal equilibrium condition. Thermal equilibrium. Thermal equilibrium. Okay, then I මේක ඔයගොල්ලන්ට ගන්න දෙන හොඳම දේ මොකක් හරි ඔබ්ජෙක්ට් එකක් මොකක් හරි කාසියක් කරන මොකක් හරි රත් කරලා නිවා ගන්න ඕන. නැත්නම් මොකක් හරි ඔබ්ජෙක්ට් එකක් නිවා ගන්න ඕන නම් මොකද කරන්නේ? Sorry. 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 මොකක් හරි ඔබ්ජෙක්ට් එකක් නිවා ගන්න ඕන මොකද රත් වෙච්ච ඔබ්ජෙක්ට් එකක් නිවා ගන්න ඕන මොකද කරනවා? අනිවාර්යයෙන් වතුරට හරි මොකක් හරි දාන්න පුළුවන්. ටිකට් වෙලා ගියාට පස්සේ මොකද වෙන්නේ? ඒක ආයේ අපි අර ඒ දෙන්නම එකම ටෙම්පරේචර් එකටපත් වෙනවා. ඒ දෙන්නම එකම ටෙම්පරේචර් එකටපත් වෙනවා. Okay. Half finish. happen. Correct. Have finished? If you finish writing, please give me a thumb. Yeah. There are this, right on this. When two objects are in thermal contact, come on, heat energy will be transferred from the higher temperature object to the lower temperature object. When two objects are in thermal contact, heat energy will be transferred from the higher temperature object to the lower temperature object. When two objects are in thermal contact, heat energy will be transferred from the higher temperature object to the lower temperature object. As a result of that, as a result of that, as a result of that, the temperature of the higher temperature object, the temperature of the higher temperature object decreases while the temperature of the lower temperature object increases. While the temperature of the lower temperature object increases. Hello. Then, another para. After a certain time, after a certain time period, temperatures of both objects, temperatures of both objects become equal. After a certain time period, temperatures of both objects become equal. Become equal. TA equal TB. TA equal TB. Good. Therefore, kinetic energy of A will be equal kinetic energy of B. Now, kinetic energies become equal. So, as a result of that, there is no net heat flow. There is no net heat flow. Therefore, as a result of that, there is no net heat flow. So once the object becomes that condition, so this condition is called thermal equilibrium condition. This condition is called thermal equilibrium condition. So once two objects become thermally equilibrium objects, or once they achieve thermal equilibrium condition, so after that, temperature of both objects become equal. Temperature of both objects becomes equal. And, therefore, we cannot increase the temperature of one object separately because both objects become temperature. If both objects are in thermal equilibrium condition. දෙන්නම ඉන්නේ thermal equilibrium condition එකේ. ඒ නිසා අපිට දැන් එතනින් පල්ලෙහාට දාන්න බෑ. එතනින් පල්ලෙහාට ඒ කියන්නේ ආයෙත් එකක් තව අඩු වෙනවා එක තව වැඩි වෙනවා එහෙම කරන්න බෑ. thermal equilibrium එකට ආවට පස්සේ heat exchange එකක් නෑ. No net heat exchange. No net heat exchange. Therefore, we cannot we cannot change the equilibrium condition. equilibrium condition එක change කරන්න බෑ. හරිද? කරන්න බෑ කියලා කියන්නේ මෙහෙමයි. කියන්නේ එකක් අපි separately ඇසලා මේ මොකක් හරි ක්‍රමයකින් heat එක දුන්නොත් කරන්න පුළුවන්. එහෙම නැතුව එහෙම කියන්නේ externally බලපෑමක් නැත්තම් if there's no external influence, then the temperature of both objects remains unchanged. Therefore, TA equal to B. That means K kinetic energy of phase A is equal kinetic energy of B. So as a result of that, there's no net heat flow. This is called thermal equilibrium condition. This is called thermal equilibrium condition. Underline that. හරියෝ. Okay. තේරෙනවද that? Therefore, therefore, come on. When two objects are in thermal equilibrium condition, when two objects are in thermal equilibrium condition, when two objects are in thermal equilibrium condition, right, there are two characteristics, okay? When two objects are in thermal equilibrium condition, number one, first characteristic is temperature of both objects are equal. Temperatures of both objects are equal. Number two, there is no net heat flow. There is no net heat flow from one object to another. There is no net heat flow from one object to another, to the other. From one object to the other. What a net heat flow? Net heat flow means heat can be transferred from A to B. It can be transferred from A to B. It can be transferred from A to B, but the same amount of heat should be transferred from B to A to B to A to. And there is no net heat flow means actually it does not mean there is no heat flow. Actually, there can be a heat flow because they are in thermal contact. They are in thermal contact. And they are in thermal contact. Therefore, heat can be transferred from A to B as well as B to A. B to A. But when they are in thermal contact, the amount of heat transfer from A to B should be equal to the amount of heat transfer from B to A during a certain time period. Change of heat energy. And I got one here. When two objects are in thermal contact, definitely temperature of both objects are equal. Temperature of both objects are equal. ඊළඟට මෙයාගේ there's no heat flow. There's no net heat flow. There's no net heat flow. Net heat flow එකක් නැහැ කියලා කියන්නේ මෙයාට 100 joule ගියොත් මෙයාට 100 joule එන්න ඕන. එහෙම නැත්නම් heat එක නැති වෙන්න පුළුවන්. flow එකක් නැති වෙන්නවත් පුළුවන්. නමුත් ගියොත් එහා සම්බන්ධ කෙන්නෝ. Is that clear? If you got that one, please raise the hand. Then also. හොඳ question එකක් ආවා ලස්සන. මොකක්ද? When two objects are in thermal contact, what happens to the heat energy? Isn't that the heat energy equals? That means QA should be equal Q. No, not Q. Heat energy of A should be equal heat energy of B. Is that okay? ඒක හරිද? ඒක හරිද? ඒක අපිට කියන්න බෑ. ඒක අපිට කියන්න බෑ. ඒක වෙන්නත් පුළුවන් නොවෙන්නත්. So what is the reason? What is the reason? Look at this one. I will explain. I will explain. Now, suppose there is object A. There is object A heated to 100 Celsius. And weight of this object A is 2 kilograms. Now, there's another object. There's another object. Sorry, there's another object which is made out of same material, and this object is at 30 Celsius, today, but the weight of this object is 10 kilograms. 10 kilograms. Now it is very clear, definitely he should be transferred from high temperature object to low temperature object. High temperature object to low temperature, because actually in this case heat energy means the kinetic energy of particle, because in this case there is no phase change. As there is no phase change, heat energy means kinetic energy of object, and therefore definitely here kinetic energy is higher than the kinetic energy of this case. Therefore, heat energy will be transferred from A to B. As a result of that, temperature of A decreases, temperature of B increases. So after a while, they will become same temperature. And at the same temperature, 60 kilograms. Make assumption, fact. Wala pulo, kamu kita mau 60 kilo. Make wala pulo, mau ingat bangga, mereka 60 kilo. දැන් මෙතනදී පුතේ මෙයාගේ තියෙන heat energy එකයි මෙයාගේ තියෙන heat energy එකයි equal. Heat energy equal නැහැ. Heat energy අපි දන්නේ equal වෙන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. දැන් හොඳම දේ මෙතනින් බලන්න. දැන් මේ same material නේ. Same material එක ගත්තොත් එහෙම මෙයාගේ තියෙන number of molecules ගාන මෙයාගේ තියෙන number of molecules ගාන ගත්තොත් එහෙම definitely මෙයාගේ number of molecules ගාන වැඩි. මෙයාගේ number of molecules ගාන වැඩි. එහෙනම් අනිවාර්යයෙන් මෙයාගේ ඇතුළේ තියෙන number of bonds, intermolecular bonds ගන්න වැඩි. ඒකත් එක්ක මෙයාගේ තුල තියෙන potential energy එක. potential energy එක අනිවාර්යෙන් වැඩි. ඒ නිසා අපිට heat එක equal කියලා කියන්න බෑ. heat එක equal කියලා කියන්න බෑ. හැබැයි මම ඊළඟ topic එකට එනවා. exchange heat එක equal. හොඳට මතක තියාගන්න එක. Okay? The heat of A and heat of B may be equal, may not be equal. I cannot assure that thing. But the exchange heat means transferred heat. That means there's a heat transfer. So during this heat transfer, there is a reduction of heat energy, and there's an increment in heat energy. So, if there is no heat loss to the surrounding, the reduction of heat energy in object A should be equal to the gain of heat energy in object B. Therefore, reduction of heat energy should be equal to the increment in heat energy. And we can say that thing. That is obvious, Putir. Then definitely, if there's no heat loss to the surrounding, definitely should be happen. But I cannot say the heat energy of A is equal heat energy of B. That is wrong. Is that clear? If you got my argument, please raise your hand. Exchange of heat is equal. Exchange of heat is equal, but heat energy may not be equal, may be equal. I don't know. ඒක අපිට calculate කරන්න ලොකු considerations ගොඩක් කතා කරන්න. Yes, Putir. It is Q. It is Q. And Q means change in heat. And the Q means change in heat. And change in heat energy in A should be equal change in heat energy in B. That is Q. Q equal MC theta කියලා අපි කියනවා change in heat energy. මේක දාගන්න. Okay. ඊළඟ දැන් මම මේ කතා කරපු topic එක. Exchange of heat energy. Next topic is exchange of heat energy. Exchange of heat energy. So, as we discussed with if a hot material is in thermal contact with the cold material, suppose TA is higher than TB. If they are thermal contact, definitely there will be a heat energy from A to B. There will be a heat energy transferred from A to B. So as a result of that, some amount of heat energy decrease from A. Some amount of heat energy is decreased from A. And so that decreased heat energy is absorbed by B. As a result of that, there's a gain in heat energy in B. Gain in heat energy in B. Therefore, during this transformation, if there's no heat losses, to the surrounding, the total heat removed from A should be equal to the heat gained by B. Heat gained by B. Therefore, when there's a heat exchange, and if there's no heat losses to the surrounding, heat loss by hot object should be equal to the heat gained by the cold object. Heat gained by the cold object. Did you get my point? තේරුණා නම් තුස්සන්නේ. ඒක තේරුණා නම් තුස්සන්නේ. I need responses from everyone. Okay. Then I do the pick and go this one. Okay. Then write down this. If a hot material, if a hot material, if a hot material is in contact with a cold material, if a hot material is in contact with a cold material, come on, the hot one cools down and the hot one cools down and loses heat energy, heat energy, heat energy. The cold one, the cold one, the cold one the cold one heats up and gains heat energy, gains heat energy. If there's no heat losses to the surrounding, if there's no heat losses to the surrounding, heat lost by the hot object should be equal to the heat gained by the cold object. Heat gained by the cold object මේක තමයි මන්තරේ. Repeat from which point පුතේ? කොතනද repeat කරාම? මේක තමයි මන්තරේ. මේක ඔළුවේ තියාගන්න ඕනේ. සමේක තේරුම් ගන්නවා. මේක තේරුම් ගන්න ඕක තමයි මන්තරේ. Calorimetry ල මන්තරේ. හරිද? Heat lost by the hot object should be equal to the heat gained by the cold object. From which point to the? From which point? What is the last point you wrote? Losses heat energy. Full stop. The cold object heats up and gains heat energy. The cold object heats up and gains something and gains heat energy. Cold object heats up and gains heat energy. If there is no heat loss to the surrounding, then you have to write this equation and highlight that. Okay? Heat lost by the hot object should be equal to heat gained by the cold object. Have we any equation here then? A කියලා object එකක් තියෙනවා. Initial temperature of A is theta A. And theta is higher than this object B. Theta A is higher than theta B. Therefore, there is a heat transfer from A to B. There's heat transfer from A to B. So as a result of that, temperature of A decreases and both objects become thermal equilibrium at temperature theta. මෙයා මේක අඩු වෙනවා පුතේ. මෙයා theta B ඉඳන් theta මේක increase මේක decrease. Suppose the mass of this object is Ma, the specific heat capacity is C. Here mass of this object is B, the specific heat capacity C. Therefore, heat lost by A. Heat lost by A. How to calculate? It is equal to Q equal MC theta. Now, how to calculate heat change? How to calculate change of heat? Change of heat is calculated by Q equal MC theta. Q equal MC theta. Therefore, heat lost by A, if I consider it as QA, it is equal MACA, and temperature difference, this is the highest one, this is the lowest one, therefore temperature difference is theta A. minus theta. Then heat gain by B. Heat gain by B. How to calculate the temperature difference? Again, Q equal MC theta. Again, Q equal MC theta. Therefore, heat gain by B, QB is equal MB, CB. Temperature difference. Initial temperature is theta B. Now theta puthe, but theta is higher than theta B. Therefore, temperature difference is theta minus theta. ලොකු එකේ පොඩි එක තමයි හැම වෙලේම අඩු කරන්නේ. මොකද එනර්ජි එක අපි ගත්තොත් ඒක නෙගටිව් වෙන්නේ නැහැ. Therefore, if there is no heat change, sorry, if there is no heat loss, if there is no heat loss by A should be equal heat gain by B. මෙයාගේ loss වෙච්ච heat එක මෙයා ගන්නවා. Therefore, if there is no heat loss, heat loss by A, heat මෙයාගෙන් අඩු වෙච්ච heat එක මෙයා අනිවාර්යෙන් අර ගන්න ඕනේ. Heat loss by A should be equal to the heat gain by B. Heat loss by should be equal heat gain by B. Therefore, okay, MAC theta A minus theta should be equal MB CB theta minus theta B. Okay. Did you get my point? मैं तेरना ना तुझसे मगर explanation है तेरना ना तुझसे पहले ना तुझसे. I need responses from everyone. मेरे तावा नितना hard take है. तेरना तो मंगाई पारा क्या देखना. तेरना ना तुझसे. I need responses from everyone, but I'm not going to respond to all. Gandhi, Shashindra. Okay, wait. मेरा दागा. Hello, Pute. Have finished. So once you complete writing, take the tube, Pute. Take the tube and turn into 17th question. 17th question. 17th question. No need to do, just read it. Taggala kyogan kyola hitin try karan on vidya karan nepa. No need to do, but build an argument. Build an argument. Read the question number 17 and build an argument. This is very, very important, Pute. Now we are going to do questions. Therefore, now we are going to solve questions in calorimetry. Therefore, you have to understand this part very, very well. And make the final output. Now, this is the final output. Okay, have finished. Shall I rest? ඉවරනම් කියපන්කො බාග් හරි අමාරුයි එකම දේ කිය නැත්තම් නෑ ඉවරනම් ඔව් හරි හරි thank you thank you හරි read the question a copper calorimeter of mass 0.12 kg contains 0.1 of liquid paraffin at 50 Celsius. 50 Celsius. Okay, now I can't do this one. Now there's a copper calorimeter. Copper calorimeter of mass 0.12 kg. Calorimeter got the mass of copper calorimeter is 0.12 kg. Contains 0.1 of kg of liquid paraffin at Celsius 50. Now, there's liquid paraffin 0.1 kg. 0.1 kg. Now, temperature of both objects are 15 Celsius. Now, when a piece of aluminium of mass 0.048 kg. Now there's a piece of aluminium which has a mass of 0.048 kg. 0.048 kg. Aluminium is equal 0.048 kg. And temperature is 100, no? 100 Celsius. Temperature is 100 Celsius. Is dropped into this liquid. Then the final temperature is 27 Celsius. 27 Celsius. Final temperature means final temperature of all elements. If specific heat capacities are given, copper and aluminium. Specific capacity of copper is 400 joule per kilogram per Celsius. Whether I don't know. Make it 1000 joule per kilogram per Celsius. Now all are here. So when you are given this kind of questions, please listen to me very carefully, everyone. Stop your work. Everyone stop your work and listen to me very carefully. When you are given this kind of question, you have to understand what is the heated object. That means what object should give heat energy. There may be several objects to say. So in our theory part, actually we have discussed only two objects. Now, in our questions, there may be more than two objects which are in thermal contact. Therefore, you have to understand all of them. The first thing you have to understand, what is the heated object? Heated object means the highest temperature one. So tell me here, what is the heated object and which object gives heat energy? Which object gives heat energy? Tell me. I need responses from everyone. මම answers දෙන්න හැමෝම මට හැමෝමගේම answer එකක් දෙන්න ඕන. කවුද මෙතන heat එක දෙන්නේ? Which object gives heat energy? I need answers. මට answers දෙන්න හැමෝම. Very good. Very good, Lasit. Very good, Lesandu. Yes. Very good, Gandhi. Anita. I need responses from everyone. Yasit. Shashendra. What are your answers? Dinit. Go, Dhamdi. Rashid. What are your answers? Tell me. I need responses from everyone. Nidhi there. Nidhi there. Who gives heat energy? Yes, Sinab. Hari. Dhamdi. Hari. Yes. Rishi Hari. Yes. Lasit. Yasit. Shashindra. Yes. All are correct. All are correct. Very good. Very good. I can hold Yes. Aluminum. Aluminum gives heat because that is the heated object. No, that is the highest temperature object. That is the highest temperature object. Therefore, aluminum gives heat energy. Second one. Please listen to this very carefully and give the correct answers. Who receive heat energy? Who receive heat energy? How the receiver? I have all the mass like heat energy. How the receiver? Who receive the heat energy? I have all had to very good. Then burn again. Who receive the heat energy? Bagete, listen to Bagete, Sinap Bagete. No, again, Dineth Bagete. Dhamdi. Yes, Kushi. You are correct. Yes, Lasit, you are correct. Yes, Shashindra, you are correct. Yes, Dirith, now you are correct. Now we again try. Zinab, you can try again. Yes, Yasit, you are correct. Yes. Yeah, you are correct. Correct. Most of you are correct. Most of you are correct, but some. හැමෝම ගොඩක් කට්ටිය එකපාරට liquid paraffin කියලා බලි කිව්වා. But there are two materials පුතේ. Not only liquid paraffin. Not only liquid paraffin, there are two objects. What are those two objects? Liquid paraffin and copper calorimeter. Copper calorimeter, because they both of them can absorb heat energy. Can absorb heat energy. දැන් නිකන් හිතන්න වතුර එකක් ලිපේ තියලා රත් කරනකොට රත් වෙන්නේ වතුර විතරද? ඈ? කේතලේ රත් වෙන්නේ නැද්ද? මාරයිනේ එහෙම නන්නේ. කේතලෙත් රත් වෙනවා. වතුර විතරක් රත් වෙන්නේ නැහැ. හරිද? Therefore, you have to understand what are the materials which are in thermal contact. There may be more than two materials put it. Then you have to understand who gives heat energy and who receives heat energy. The most heated object, the most heated object is the one who gives heat energy. The other objects will be receive heat energy. Will receive heat energy. Therefore, here aluminium piece is the object who gives heat energy, and liquid paraffin and copper calorimeter are the two objects who gain that heat energy. හොඳට ඔරුවට ගන්න අර එක්සැම්පල් එක. වතුර එකක් ලිපේ තියලා රත් කරනකොට වතුර විතරක් නෙවෙයි රත් වෙන්නේ, කේතලෙත් රත් වෙනවා. හරිද? ඒ දෙන්නම heat absorb කරගන්න. දැන් මෙයාට පුළුවන් මුත් object එක මුත් material එක උඩ heat එක absorb කරගන්න පුළුවන්. He can absorb heat with it. Therefore, I can write an equation which suit for this phenomena put it. Therefore, who lost heat put it? Heat loss by aluminium piece is equal heat gain by liquid paraffin plus copper. Liquid paraffin plus copper calorimeter. හැම වෙලේම මෙන්න මේ equation එක ලියන්න ඕනේ. You have to write this equation in every year. Then definitely you won't be wrong. Because you know who gives heat and you know who receives heat. So if you try to write this argument, then definitely there won't be any mistake. And therefore, heat loss by aluminium piece is equal Q equal MC theta M aluminium C aluminium and theta aluminium is equal heat gained by liquid paraffin plus copper calorimeter. Therefore, heat gained by liquid paraffin means M paraffin, C paraffin, theta paraffin plus heat gained by copper calorimeter is equal M copper, C copper, theta copper. Then අපි replace කරමු. M aluminium is equal 0.048. අපි මෙතන kilograms වලින් හැම එකක්ම තියෙන නිසා හැම එකම kilograms වලින් දාගන්න. හැම එකම grams වලින් තිබ්බොත් හැම එකම grams වලින් තියාගන්න. No need to convert it into kilogram. C aluminium is 1000 පුතේ. C aluminium is 1000 10 to the power 3 Delta theta, initial temperature of aluminum is 100. Initial temperature of aluminum is 100. Final temperature is 27. Therefore, delta theta is 73. Is equal. M paraffin is 0.1. C paraffin to be determined. Theta paraffin is equal 15 to 27. That means 12 plus M copper is 0.12. C copper is 400. Theta copper also 12. Also 12. Also 12. 15 to 27, 12. I think I can cancel out all of them by 12. By 12. 12 to 12. Method 4 in 0.004. 0.004 කියන එක කියන්නේ මට මේක කියලා 4 කියන ගත්ත හැකි. Therefore 4 into 73. 4 into 73 means 12. Okay, so let me see. I think 29. 29 minus this one. මෙතන දෙකයි මේකයි යනවා 40 into 12 is 48 නේ 48. Is equal 0.1 CP. Alright. විශේෂයෙන්ම දෙකේ 40ට කියන් කියලා බලන්න අතරයි 0.1 CP. CP කියන්නේ නම් 2 joule kilogram. This is 244 0. Alright. Minus 73, 73, and 2440. 2440. 240. බලන්න 70, 27. 400 440 වෙනවා. Okay. If you got my argument, if you got my calculation, please raise the hand. මේ තේරුණා තුස්සන් මම අපි කතා කරපු. I need responses from everyone. But I won't give respond එක වගේ. Very good. Yeah. amount of තේරුණා මොනවද කියලා. එන මේක දාගන්න. Then try to do question number 80. Question number 80. අපේ එකින් යන්න හොඳට. අපේ එකින් යන්න question number 18 ටක් ගලපන්න. Question number 18. I finish. Question number 18. මෙයාගේ තමයි. Okay, පුතේ. The calorimeter of mass 0.09 the calorimeter of mass 0.09 contains 0.09 of water at temperature of Celsius 60. Now this calorimeter has a mass of calorimeter is equal 0.09 kilogram, contains mass of water 0.09 kilogram, and temperature is 60. Temperature 60 Celsius. And what will be the final temperature of the mixture when a piece of iron of mass 0.2 kg heated to 100 Celsius drop into the water? Now there's a piece of iron of 0.2 kg mass and heated up to 100 Celsius and drop into this water. What would be the final temperature? That is our question. That is our question. Then we are given the heat capacity of water calorimeter and iron. Water calorimeter and iron. Water calorimeter, sorry, water 4200, make 800, make 400 for degree. I think Marlon Pathirage water kilo. Iron එකයි calorimeter Marlon Pathirage මොට්ට බල ගමන විල් දින දිලා kilogram, sorry, joule per kilogram. Joule per kilogram per Celsius. Joule per kilogram per Celsius means joule per kilogram per Celsius. Now tell me who lost or who gives heat energy? Who gives heat energy? Tag again, I need responses from anyone. Who gives heat energy in this case? Who gives heat energy? How the heat energy then? Yes. Yes. Very good. Andy. Antai. Yes, iron. Yes, Harry. Yes. Yes, very good. Synapse. Yes, sir. Yes, all are correct. All are correct. And who receives heat energy? Who receives heat energy? How the gun? Who receives heat energy? How the gun? Yes, very good. Yes, more 10 calorimeter. Yes. Yes. Very good. Yes. All are correct. All are correct. Calorimeter plus water. Therefore, heat loss. Therefore, my equation is heat loss by Fe, the iron, is equal heat gain by water plus calorimeter. Water plus calorimeter. Therefore, I can write the equation Q equal mc theta for the heat loss. Therefore, M iron C iron theta iron is equal heat gain by water, M water, C water, and theta water plus M calorimeter, C calorimeter, theta calorimeter. මට හිතෙන්නේ පුතේ මේ C එක මාරු වෙන්න ඕනේ වෙයි කියලා. බලමු. හැදුවද? ඔය ආන්සර් ගාවද? බලමු කවන්න වෙයි. දින විදිහට. M iron 0.2, C ඇවිල්ලා 400. Suppose the final temperature is theta. Suppose the final temperature is theta. That means 100 minus theta. That is the temperature difference. The temperature difference of both calorimeter and water should be equal because initial temperature of both of them are equal with the final temperature of both of them are equal. Therefore, temperature difference in water and calorimeter both are equal. Therefore, I can take it as a common factor. MW is 0.09, CW is 400 to 4200 plus MC 0.09 into 800. මෙතන common factor එකක් තියෙනවා ඒක නිසා මෙතන දීලා නැත්තේ into theta minus 60. Theta minus 60. So you can take 0.09 out because it is common factor. Therefore, 4,200 plus 800 means 5,000. 5,000. Therefore, 48 to 2, 42 means 80. 100 minus theta is equal. මෙතන පුතේ අපි ගත්තොත් එහෙම 5,000 and 5,000 into 9 means 9 into 5, 50. 9 into 50. 9 into 50. Theta minus 60. මේකට වෙයි කරනවා 800 into 8 theta is equal 45 theta minus 45 into 16. 45 into 16 means මේක මෙතන ගෙනියනකොට එතකොට 1,520 is equal 53 theta here. 53 theta. එතකොට 1,520 මෙතන 53 ගත්තොත් එහෙම මෙතන 2යි. അതൊക്കെ നാസം 28.17. 28.7. మన ఇదైన విధంగా మారువేడినోళ్ళు 800 400 ఏరియా మారువేడినోళ్ళు ఒకటి వెన్నతి धीरे धीरे असर के वो सामान्य कोपोवल ने कुते हारसी कोपोवल हारसी आयन वाले हारसी तमा आयन ये तो मारुवेडिनोళ్ళు if you got my calculation please share them मैं तेरे ना तुझसे मैं आगे responses पर मिलेगा very good very good बहुत है मेरे तमा मैं कैलकुलेट कर दी अम्मा बोले मार गए सी है कैलकुलेट कर मैं कहता मार दी नीचे पास अभी कथा करना फेस चेंज है तब मैं within the phase change now there is no phase change. So there's another condition when there's a phase change. When there's a phase change, how to determine heat exchange? We have to calculate or we have to determine that thing. So that is a final step. So after that, calorimeter part will be over. I'll make it a question so you can see it. Like over and pull me you take another movie. Okay, now you can come actually not complete, but you can do most of the questions in this tute. And please go through the tute. Please go through the tute, especially from question number 17 onwards. Question number 17 onwards. You can do those questions using this knowledge. Not only those questions, but also you have to do the previous questions. Question number 1 to 17. And please go through the questions and do as much as possible. As much as possible. අතාරින්න එපා අනිවාර්යෙන් කරන්න. නිකන් ඉන්න එපා මම ඒකයි කියන්නේ. මොකද මට ඔක්කොම questions හදන්න බෑනේ පුතේ මම ඔය තෝරාගත්ත questions ටිකක් තමයි හදන්නේ. අනිවාර්යෙන් tube එක ඉවර කරන්න. You have to complete the tube puti. Some questions, in some questions, there may be situations like phase changes. So, expect those questions. You can do all the others. You can do all the others. Therefore, please go through the tube and do as much as possible. Because now you know the theory. I know you have understood that thing very well. Therefore, don't miss that opportunity. Go through the tube and complete all you can. Okay. So we can complete today's lesson, Puti. If you have any questions, please let me know. If you have any questions, please let me know. And we have almost finished the lesson. Email. If you got or if you understood this lesson, please let me know. Thank you. Thank you. Okay. You answers very well. You answers very well. Therefore, I know you have understood very well. So please go through the tube and confirm your knowledge. Otherwise, you may lost your memory. Memory okay. So we can complete today's lesson. Puti din everyone. Good night, everyone.
Thank you, sir. Good night, sir.
Yeah, welcome, Putin. Yeah, welcome.